Okay, well, good morning today. Hey, I'm going to give you a quick update on kind of what we're doing. I was planning on getting started today with section 1.1, and we're going to actually combine it with 1.4. But when I went to assign it, there's a setting in my college algebra text on my program that would not allow me to assign it before the 15th. So that gives me one more day that I thought I'd go ahead and do just a quick tutorial on logarithms, and this is actually chapter 4, so we won't cover logs until I think in my plans it's kind of like right about March or maybe the first part of April, maybe kind of in that part. But I wanted to just give a simple explanation. We just do part of this lesson and then give you guys just a tutorial to kind of look over. I'll also have your college syllabus ready to go that you can preview on Wednesday too. So we'll kind of go over specifics about the college class once you guys can get logged in to the college class. So with that, when I talk about logarithm functions, keep in mind, logarithms are just exponents, okay? So when I think about, all of the properties that are associated with exponents will also apply to logarithms. One of the things that you really do need to know is to be able to go from a logarithmic form to an exponential form. And keep in mind, when you do the exponent, when I say like the logarithmic form this would be read as y equals log base b of x. And the base is always going to be the little number on the side, or down below. You will also sometimes will see a couple of if I just have a log that has no base on it, then you will automatically assume that it's base 10. But when you look at your calculator, you have a calculator and it has a log button and it doesn't have a base on it. A lot of our calculators now, you can actually input that in, but if there's nothing inputted, we assume log base 10. You'll also see on your calculator that you have an ln function, and an ln function is just the log of e. And E is going to be Euler's number, which we'll talk about more in, down the road on why we use E. But in terms of like, some of your when we get into some of your calculus and your upper level math, E is used a lot in terms of just a standard number, and it's an irrational number similar to pi, but it's approximately about 2.7. So with that, when I go from logarithmic form to exponential form, my base will always stay the same. So it's going to be a number, and my exponent will be what it's equal to. So it's going to be b to the y equals x. So these two statements, y equals log base b of x and b to the y equals x, are saying the exact same thing. So when I start off, write the expression in its equivalent form. Remember if I'm going to go 2 equals log base 9 of x, then I'm going to start by identifying my base. And so my base is going to be 9. Okay, the logarithm, this part, whatever it's equal to, is always going to be your power. So this means 9 to the second power is going to equal x. And then anytime you can simplify, anytime you have this situation, you want to go ahead and tell me, then change that. So 9 squared is, Kirsten? 81. And so you'll have 81 is equal to x. So I also need to go the other way. So in other words, if I have 8 to the y power is equal to 300, I'm going to start off by saying log. My base is going to be what again? Okay, should be the number taken to a power, so it's going to be log base 8 of, now remember we're going to say that it's going to be then of 300, because if you notice on this one, I'm going to have my power being equal to it. So it's log base 300 of y. And that actually has a value. It's what it's saying is y to 8 to what power is going to be equal to 300, and then you could actually put that into your calculator, and we're going to show that to you when we get to section 4 a little bit more. But today we're going to do all things all of my assignments today, or all from the problems that I'm going to give you, can be done without a calculator. And so even though you can, I'd really like you to try not to. So let me start off with the first one. So you have log base 3 of 81. So we start off, to me it makes sense to go ahead and change that over to your exponential. So in other words, I'm going to let this equal x, and I'm going to just change that 3 to the x is equal to 81. And then I want, if you want, change the 81. 81 is actually 3 to the what power? 3 times 3 times 3 is 27, times one more 3 to the fourth is going to be 81. So 3 to the fourth is equal to 3 to the x, and therefore log base 3 of 81 is just going to equal 4. If I have the same thing over here, I'm going to put on this side. So I have 3 to what power is equal to 1/9. Now, in this case, if this is a fraction, you're going to also make sure that your exponent then, remember, is going to have to be a negative number. So I'm going to actually say that, I'm going to say, well, I can change either one. I can go 1/9, I can move that up, and I say, well, I have 9 is actually 3 to what power? Squared, yep, to the second. So if I know that 3 to the x is going to equal 1 over 9, which is also 1 over 3 to the second power, then to make this so that the 3 is in the top part of my fraction, remember the rule we had with modern college math was that if you cross the line, you change the sign. And so that's the same as going to be -2, so that means this is going to be -2. So let's do this next one. Now this one is a little different too when I have 81 where my base is larger than my number. So if my base is larger than my number, so it's 81 to what power, so let's go ahead and say equal x is equal to 9. Now hopefully you look and say, well, wait a minute. 9 is the same thing. If I know 9 squared is 81, but I can't change the 9 here to make that. So in other words, I want to think about in terms of what can I take, what power would I take 81 to, so it would be equal to 9. And I know that if I take 81 and I take actually the square root of the 81, that's going to equal 9. But when I write it there, 81 to the 1/2 power is also equal to 9. This is another way to write the square root, is making it to the 1/2 power. So in this case, when I have the log base 81 of 9, it's going to equal 1/2. So keep in mind, fractions are going to give you a clue that you're probably going to have a negative number, but then you're going to also, if you have a number where your log is bigger than your base, or log is bigger than what you're taking the log of, if your base is bigger, then you're going to have a root, and you'll write the exponent as a fraction. Couple of rules. One thing that you do, anytime I'm going to take, if I have log base b of b, okay, so in other words, it's the same thing. So in other words, if I go log, and I'm just going to say my favorite number, 7 of 7. Remember, that means 7 to what power is equal to 7, and you'd probably have to say it has to be 1, right? I mean, 7 to the first power. So this is when anytime your base and what you're taking the log of is exactly the same number, it's going to be then equal to 1. Now also it works off if I have log base 7 and I have of 1. So you're saying 7 to what power is equal to 1, and 7 to the 0 power is all 1. So anytime this number in here, and when you change it from your exponential form, like the x that we had earlier, if it ever is equal to 1, whatever you're taking the log of will always be 0. So it doesn't matter what the base is. I could put just log of 1. I could also go log base 5 of 1 is always going to equal 0. We also know that whatever is inside here, okay, in other words, when I go back to my exponential form and it's the x has to be a number larger than 1. It can never be negative. So, or sorry, larger than 0, excuse me, larger than 0, it can never be a negative number. So anytime you see, if I ever had log base 5 of a negative 5, then you know that this is a null set or it doesn't exist because you can't take a log of a negative number. So with that, if I have a log base b of b to the x, here's another rule that's saying, remember, if I have log base 5 of 5 to the third power, remember rewriting it is going to be 5 to the x is going to equal 5 to the third. Well, that means that this is just going to equal the power, so it's going to be 3. So that's just a rule that we have. And then if you have the base to the power of log base b of x, it's also going to be equal to x. So let me just jump in. We're going to do a few problems that I want you to practice with. Again, you can do you can use your calculator to check. You don't have to though. So in this case, I'm going to say 5 to what power is equal to 25. So for 25, we're going to change to 5 to what power? Yep. So I know that log base 5 of 25 is just going to equal 2. I have a fraction on this one, so it's 1 over 25. So in other words, this one would just be, have a guess? Yeah, this, okay, so let me write it as 5 to what power is equal to 1 over 25. And then we're going to change 1 over 25 to 5 to what power? 5 squared. And then that's the same as 5 to the negative 2 power. And so that I know that my missing part will be then just negative 2, my power. So this one's going to be negative 2. If I have log base 4 of 64, it's 4 to the, so it's 4 to the 4th. So it's 4. Log base 2 of 8. 8 is actually 2 to what power? Third. Very good. So this is going to equal 3. Here's our 1. What happens if I have, it's saying 2 to what power is equal to 1, and that has to be? Close. So remember 2 to, if I had, okay, she said 1. Let me show you. Log base 2 of 2, that would equal 1. But log base 2 of 1 means you're saying 2 to what power is equal to 1, so it has to equal 0. So this one is actually 0. Log of 1,000, remember this is actually what base? 10. So it's actually 10 to what power is equal to 1,000? Third. So this is going to equal 3. Good. Okay, this one's kind of interesting. I didn't write it as a fraction, but remember it's log of 0.1. 0.1, you could write it as 10 to what power is equal to 1 over 10, if that would help, because that's the same as 1/10. And 1/10, this is 10 to what power? Go negative, because it's going to be, so right now it's 1, so it's negative 1. So in other words, log of 0.1 is equal to negative 1. Kind of getting it, kind of work close. What about the log of 0.01? You got the idea with 2. What are we going to have to do with the 2? So let me write it over here. I have log of 0.01, which is the same as 10 to what power is equal to 1. How do we rewrite? Over 100. Then change the 100. That's going to be 10 to what power? Second. Good. And then I need to bring this to the top. So that equals then 10 to the negative 2 power. So log of 0.01 is equal to negative 2. Here's one that I wanted to at least get down to this one, because log base 2 of negative 2, don't be tricked. That's actually because this is a negative number in here. This one does not exist. Now, what I want to do is show you real quick also. You can check, because you're going to be able to use your calculator. I'm not going to prevent you from your calculator. But most calculators we'll have a log button, and this mine is a little bit different. Do you? I know that some of the other kids that had the class last year was a little bit different. This one's for me to find it. It's going down to number 9, and then I can put in log base. So in other words, it puts a square as 5, and let's say I had 25, and then I could hit then enter, and I'd get the 2. So your calculators will also do this problem. Remember, I already have the log here in here, and this is 10 base 10. So if just the sorry. You get down. So if I wanted to go log, we just did the problem 0.01, and I hit enter. That's where I'm going to get the -2. Check your calculator, and if you need me to help you with find those log functions, let me know what kind of calculator you have, and I'll help you show it. But try and do them, the last of these, the last 5 of them, on your own, and then we'll see if and then you can check them with your calculator.